right? It may be a little less likely that you had this, but maybe if you took like AP biology or something like that, you might have had it, right? The approximate number of fruit flies in an experimental population after T hours is given by this function, where I should have added that the T is greater than or equal to 0, which makes sense because we're going forward in time. So this is a population growth. So notice that the base is E, right? And E is greater than 1, so this is definitely exponential growth. How do we find the initial number of fruit flies? Plug in 0. What will the answer be? 20, right? It's always that constant that's in front. I mean, you could plug it in, but remember, e to the 0.03 times 0 is e to the 0, and e to the 0 is 1, so the answer is 20. How do we find the number of fruit flies after 72 hours? Plug in 72, right? Q of 72 is 20 times e to the 0.03 times 72. And I think that's 173. Okay, and then we're going to sketch the graph. Okay, well, when they say sketch, to me it implies something other than put it in the calculator and just copy the graph. I mean, we should understand what this graph is going to look like, more or less, shouldn't we? It's exponential growth. We kind of know that it's going to go like that. What will the y-intercept be? It'll be the 20, right? So, and we have a point. We have 1 point, right? We have the point 72, 173 should be a point on the graph. So if I sketch that graph here, right? So 20 is the y-intercept. That's the initial amount, 20. And we know that it has this kind of a shape, but the domain is t greater than or equal to 0. So you wouldn't draw it to the left because t can't be a negative number. And we have a point which is 72, maybe about there, and 173, maybe about there. Right? That's our 72, 173 from the previous slide. And then you're going to just draw some kind of exponential growth. Any questions on that? Get it?